this last section of Chapter 4 basically ties in all the other sections from this chapter. Okay, so here's how it does that. Complex fractions. Complex fractions are simply a fraction within a fraction. So if you have one overall fraction and it's made up of either one or more fractions inside of that, then it's called a complex fraction. And there's two methods to use to solve this. And I'm just going to talk about the first method today because it basically reviews the rest of Chapter 4. I'll talk about the second method next class. Okay, so this first method includes the following steps. The first thing that you're going to do is you're going to rewrite each of the individual fractions. So whatever fraction is in the numerator and or denominator as single fractions. Okay, so your first step is to rewrite each fraction, or each, I'm going to rephrase that. Rewrite each set of fractions. In the numerator and or denominator, again depending where it occurs. As single fractions. And basically you're doing what we just did in the last section, okay, which is you're going to add and subtract your fractions. So in this case, if we look at our numerator here, what is the LCD of that? Here, just in this numerator, anytime you're given just a number, I would strongly encourage you to rewrite it in fraction form, just as a fraction bar over 1. So when you look at this, you have 1, 1, and x. So your LCD is x. And now all you need to do is take the numerator of your first fraction times what LCD factor was missing from its denominator. It was missing an x. So we multiply x times x, we get x squared. Plus our next fraction's numerator, which is 1, times what LCD factor was missing from its denominator. It's also missing the x. And then minus 6, the next fraction's numerator, times what LCD factor is missing from its denominator. Nothing. So you just leave it as it is. So here is our entire numerator written as a single fraction. And now we're going to do the same thing with our denominator. Well, in our denominator, it's already written as one fraction. So that's all you need to do is just rewrite it. Okay, once you do this, you should have, it's still a complex fraction, so it's still a fraction within a fraction. However, if you interpret this fraction bar as division, you're just going to take those resulting fractions and you divide them. And basically when you divide two fractions, dividing is equivalent as doing what? Invert and multiply. Okay, so this is basically what we did in section 4.2. Okay, so after we do the rewriting of the fractions, we can now invert and multiply. So all we need to do here is factor our first fraction. So this numerator does have binomial factors. The two factors of negative 6, whose sum is positive 1, is negative 2, positive 3, all over x. When we invert and multiply, the 1 gets moved to the denominator, the x gets moved to the numerator. We go ahead and simplify. As our final step, and simplifying is what we did in section 4.1. So we simplify here, the x's cancel. We're left with an x minus 2 and an x plus 3. Okay, so this is our solution. Notice we have a factor getting canceled from our denominator, so we do have to identify that excluded value. X cannot be 0. And then the other thing to keep in mind is because we're dividing here, remember when we invert and multiply, you need to look at every factor of this this fraction you're dividing by, because none of those factors can be 0, either the numerator or the denominator, because whichever one is in the numerator when you invert and multiply was in the original fraction's denominator. So you have to exclude every factor in that whole inverted fraction. Here, it's been canceled out, so you don't have to worry about it, but do keep that in mind. All right.